Alright folks, for a little update on the E39 project. As you can hopefully see here, we started to get the motor back together again. So what we're looking at here is the main frame, which carries the field coils. And what I've done so far has been to take the whole motor apart, steam clean it, get it. There was some old welded on brackets on there, they're all gone. Everything's cleaned up nicely. And what I've done this morning has been to get it painted and to reinstall the field coils. So what I want to show here now is a few of the modifications that have been done to make this motor more suitable for an electric vehicle than from its original application of driving a forklift. So first thing that we've done, try and get an extra bit of light on here, I never seem to have enough light. So the first thing that we've done has been to come along on our field coils. I hope you can see these white lumps here. These were the interconnects where the individual field coils connected together to form the series field. So we've came along and wrapped all of those connections. They're just basically M8 bolted connections. They were bare. Been wrapped with conventional PTFE plumbing tape. This is sold for pipe jointing, that kind of thing, for domestic and industrial plumbing. So I put a good few layers of wrap onto each of those interconnects. Now the purpose of using PTFE tape is that it can take the high temperatures that will be experienced inside the motor housing and windings. Conventional PVC tape would simply disintegrate and probably cause more problems than it would solve. Second modification here was on the actual bolt terminals that carry the field power, and will ultimately have the two there for the armature power. These were originally 6mm bolts. When I had the casing cleaned down, I re-drilled the casing to accept 8mm bolts. I installed new brass bolts here for the field coils. And lastly then, more of an aesthetic thing than anything else, was I replaced the bolts that hold in the field coils with stainless bolts. So that's the modifications on the main part of the motor frame. Also there was a one of these grills, kind of a mesh grill, both here on the commutator end and on the drive end for keeping out the debris. They've been taken away because there's going to be a solid band placed around both ends for the external air blower. So moving over here to the bench, as you can see, we've started to reassemble the brush gear onto the brush plate. There's 4 of these brush carriers that have to be replaced onto the pillars. They have to have the height set on them. The simplest way to do that will be just to put the armature standing up in here and adjust them with a vernier. So we'll be doing that. Reinstalling the interconnect wires and then getting this baby here bolted back in on to the commutator end of the housing. Now also on the commutator end plate there was a mesh grill on here. That's been taken off. We've got some M6 holes drilled and tapped here, because there's going to be a disc placed down over this and sealed, basically sealing off the commutator end plate from any debris or etc. that might try to get in there. So the last piece of the puzzle is the drive end cap, which is this guy here. There's a lot of protrusions and things on that, brackets that have been cut off, and the plate was milled off to a flat surface on the milling machine, painted, and basically we're going to be running through the adapter plate, which is that big lump of aluminium hiding under that little brown box over there. We're going to be going through the procedure for locating the holes to match that on the adapter plate, and making the adapter plate and setting the gearbox on it and all that kind of thing. We'll be going through very soon, hopefully. Okay folks, see you soon. Alrighty guys, just finished setting the brush height. It's a very straightforward procedure. As you can see, we have the armature just sitting upside down on the bench with the commutator end sitting upwards. I also decided to go ahead and drill out the end cap over the bearing here so we can get our tack sender installed there the same way as I did the previous one. So to set the brush height, what we want to do is to come in here, and I hope we'll see this here on camera, but you can see the way we've got this little edge here of the brush wear, just where my fingernail is. So you got your 4 brush holders. So just for this one here, what you want to do is take a brush, pop it in, and just see, hopefully be able to see there where it sits, and you want to adjust your brush height so that the edge of the brush is just sitting on the where it should be on the wear part of the commutator there. So that's really it. And you set all 4 of your brush holders the same way, and that's it, straightforward as that. Well, I'm going to fire ahead and get the brush box back together, and we'll go ahead with the reassembly of the motor. See you soon. Alrighty, so have our 4 brush carriers back on. We have the interconnect wires connected in, and the purpose of these guys is to basically connect adjacent brush carriers together in parallel. We've set the height as I just demonstrated. So I've also gone ahead here on the motor frame and reinstalled the armature cables. Some nice new bolts on there, so they're all set to go. You can see we got our 4 terminals on there now. And what I am doing on just on those inside side of the bolts, I can find it. I'm using some conformal coating spray. This stuff's good up to 200 degrees C, so just giving it a dart there just on the exposed terminals, just to help give them a little bit of insulation. So I'm going to go ahead now and get that brush plate assembly back in, get it hooked up, and now we'll look at putting in the armature. Alright, now we got our commutator end plate on, brush gear hooked up. As we can see from the grooves, I've pushed it to max advance. Hopefully that'll be enough. And I'm going to make a prediction now that I'm probably going to have to end up taking that off at some point in the next few months and milling those out more, but we'll see what we get. Okay, so the next phase of the operation is lining up some of the holes on the adapter plate. So what we've got here, as I explained before, so we have an E39 gearbox, and we have the drive end plate from the motor, and we have a piece of aluminium, 25mm thick plate, and I believe it's 400mm square. Expensive thing to get, but kind of decided I had to up my game a little bit with this build and not go with the old steel plate. So what we have to do first of all is to just by eye line up the motor end bell with the first motion shaft in the gearbox. So what I've done, so just step the plate up there just with a nut, so that just by eye, just looking in there, I've got my input shaft pretty much central in the hole where the motor armature will be coming through. So there we go. As you might notice, I've chopped the spigot off from the end of the shaft, and the reason for doing so is that we will be this will be a clutchless coupler system. So what we're going to do now is I can now see I'm about the thickness of that nut that I need to come up from the bottom of the plate. So what I'm going to do, I'm going to put my plate down flat, hopefully not mess up my fingers. There we go. Plate down flat on the bench. Take my end bell. Boom. Sit that end plate down like so, top of the aluminium. Going to get our little nut that we use as a spacer. Going to sit it down the bottom like so, and then we're just going to move the end bell down so that it's approximately sitting there on the edge with the nut. And take a step back from that, we can see that we have the motor end plate sitting on top of the aluminium plate. So what we'll do is we'll take a rule and get these spaces here the same. Then we're going to come along and mark the center. And once we have that done, we'll be using our transfer punches there to locate these holes, 6 holes in the plate. We'll be drilling clearance holes there and sinking them, countersinking them for these M8 cap screws. And that will bolt all the way through the aluminium, through the drive end plate and into the frame of the motor. So that'll hang the, essentially the gearbox will be hanging from the motor frame, not from the actual end plate bell or whatever you want to call it. So that's about the size of it, and probably going to crack on with that, and I'll do a few more intermediate stages, and hopefully we'll get this thing, we'll get this motor spinning up pretty soon. Okay folks, our adapter plate set up on the milling table, and we have our clearance holes for the mounting bolts to go into the motor frame drilled. We have identified the center hole for the motor shaft, and we're set up on the milling table here with a rather large 105mm hole saw. So the aim of the game is to remove a 105mm hole from here. didn't have a howitzer handy, so I figured this was the best way to do it. No idea if this is going to work, so figured it'll either be educational or entertaining. My guess is going to be entertaining when something binds and a 3 horsepower 3-phase motor feeding through a reduction box meets an immovable object. So without further ado, let's see if we can break something. Or drill a hole, one or the other. Not sure whether to try it at high RPM or low RPM. Probably going to squeal at high RPM, but we'll try it on that first of all. So we have a green clear, brake is off, and see what she does. Try low RPMs. That did not sound happy to me. Alright, see if the whole gearbox still works. Looks good. Yeah, I think we're in gear. Let's try that. Making a 25mm hole through this thing, but we'll come back when it's done. Well, the good news is, drilled the hole. Ended up going back to high speed because I figured the colour was kind of more effective that way. And yeah, it just went through it, made a lot of noise, sprayed aluminium swarf and coolant everywhere, but apart from that, we're good to go. So, not a total disaster, which is always helpful. Time to clean up the mess, and we'll go and see how the thing sits on top of the plate. And on top of the motor, I should say, we'll start to reassemble the motor and sit this guy on top of it and see how it all fares out. Back soon. Okay guys, motor is back together. Armature's in, and we've got the holes on the drive end lined up, and new bearings installed. They're just standard bearings, so should do that as a matter of course. So what we're going to do now, going to introduce just the adapter plate here, just to see roughly what we've got. Get a few bolts, see if we can line it up. So it's just in its basic square format at the minute, which is satisfactory for what we're doing. Haven't installed the brushes back into the motor. Doing that soon enough. Be able to give it a first run. So what we're looking for now is just to see if the see if we can get the bolts into the adapter plate. So as I said before, these bolts go all the way through the adapter plate, through the end bell, and they go into the frame of the motor. So that's the way we're doing it on this one, not least of which because it was the only real practical way to do it. Let's see if these will tighten down. And what we'll be doing then will be to find the hex keys here. Okay, have those. But what we'll be doing then will be to drill the hole in the top of the gearbox bell housing, and we'll sit the gearbox on there just to get a first impression of how it's going to look just with the shafts. I have a suspicion I'm going to have to mill out another part of this here, but we'll cross that bridge when we come to it. So kind of paint by numbers what we're doing here. So let's see how we get on with it. Try and get all of these started. Obviously once we have the gearbox mounted on here, we'll be drawing a profile around the waste bits of the adapter plate. It's not wanting to play. There's always one, isn't there? Let's have a look and see what we've got. These will be lined up. Just doesn't want to play ball. There we go. So, yeah, that's about where we're at so far. This is my first foray with an aluminium adapter plate. So far so good. Certainly should help to keep the weight and the corrosion elements down. Now obviously when these bolts are going in for the final time, we'll be putting high strength thread lock on there, but just for these fits when we're still working on it, they just go in dry, a little bit of a nip on them. And yeah, so far so good. So no showstoppers thus far. Just the real fun part is usually the coupler. So we've got to get that very accurate and solid. transmit the power from the motor into the gearbox. There's a suspicion that even with a 500 amp controller on it, I think this motor would be a bit of a torque monster. And I'm aiming for 1,000 or 1,200 amp anyway. And we'll see what we get. We'll just get a big bang, or a big flash, or a very fast car. Well, fast accelerating car anyway. Tis a land yacht. So that's it. So far so good. Adapter plate sitting on to motor and bolted in place, bolts going through into the motor frame. So that is that stage. It's going to come along and drill a hole in this gearbox, and we'll see what we get. I have a feeling I'm going to be chopping this nose tread off here. I don't think that's something we're going to need. I just don't think that's something we're going to need. Previous motor, and a little bit better in that there was a hole drilled and tapped through the centre of the shaft. But this one has a solid shaft and a nail tread on it, so I think we're going to buzz that off with the grinder probably. Yeah, and there are a couple to sit down into it, which I think it's a pity I didn't have a slightly bigger hole saw, but there you go. If necessary, what I'll do is I'll just set it up on the milling table and just basically square that up. Not the nicest way to do it, but end of the day, who's going to see the thing? So it'll be in there. It won't affect the structural integrity of the plate, so yeah, I think we're okay. Right, back with more soon. Alrighty, so as I'm hoping we can see, have our gearbox sitting on our adapter plate bolted to the motor. So as I suspected, the nose tread was hitting the gearbox input shaft, and as we don't need that tread anyway, I scheduled a procedure with my shiny new angle grinder, and we got rid of the hot nose tread. So if we now take a look into this, oh yes, I also scheduled a procedure for the gearbox to encounter a 60mm hole saw. So if we go inwards, I might get a bit of extra light on it. Okay. Bit of the old manual focus. There we go. Look at that. Who said this camcorder was crap? Anyway, we can see there that on the top we have our gearbox input shaft. On the bottom have our motor shaft. And they're both spline shafts, and we have a spline to fit the motor, and we obviously have the clutch center which will fit the gearbox input. So that is the state of play as of now. So I'm going to get working on the coupler, have some of the bits made, going to have to modify and cajole a little bit. Once we have it spinning, it's spinning through, we can mount the gearbox, spin up the motor, make sure there's no play in it, and once that is done, we can come along with our transfer punches, locate the holes around the bell housing into the plate, drill and tap, mark around the plate then with a marker, and then either mill or jigsaw the excess material away, and that is our powertrain. So quite a bit to do still, but quite a bit of progress all the same. In case some people were wondering, this is a clutchless adapter that I'm doing, same as the one I did in the E36. The E36 shifts perfectly without a clutch with an 11-inch motor, and I don't see a need for a clutch. This is a personal choice. Some people do. There's arguments for and against. I suggest if anybody is unsure, have a look around, search the forums, and make the best choice for yourselves. But as my main argument against the clutch, the coupler, is primarily that a clutch is a wear item, and very few clutches can, well, very few non-racing type clutches can tolerate a couple hundred foot-pounds at 5 RPM, and they tend to slip. So that's about where we're at, and so we'll be back soon with some coupler action, and stay tuned. Oh, and Merry Christmas.